Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Probability distributions, lecture 2. In this lecture, I will use the work of Miss Sabah Bilal Kamar of class 2020 Lyceum. Here is the list of important questions. In this lecture, I will discuss the important questions of this chapter. Some important questions of this chapter, in fact. An important advice for me and for everyone: be of benefit to others. Question number 2. In a particular discrete probability distribution, the random variable x takes the value 1 upon 120 upon r with probability r upon 45. Now this means x is equal to 120 upon r is equal to r upon 45. This statement, x takes the value 120 upon r with probability r upon 45, means this equation, where r takes all integer values from 1 to 9 inclusive. It's here. Part 1, show that probability x40 is 1 upon 15. For x is equal to 40, the value of r should be 3 here. Because when you will put 3 here, this will become 40. So r should be 3 here and here. So when you will put 3 here, you will get 1 upon 15. Here is the answer. Part 2, construct the probability distribution table for x. This is very simple. R can take these values 1 to 9 inclusive. Therefore x will take these values 120 to 13.3. When you will put r1 here, you will get 120. When you will put r2 here, x will be 60. When the r is 3, x will be 40, and so on. Similarly, you can get the corresponding probabilities of x. Part 3, which is the modal value of x? Modal value means the value of x which has the highest probability. Therefore, this observation 13.3 has the highest probability, which is 9 upon 45. Hence, the required value of x is 13.3. Find the probability that x lies between 18 and 100. Now this is very simple. This number from 20 to 60, these numbers lie between 18 and 100. Therefore, we just need to add the probabilities of these numbers, these 5 numbers. 6 upon 45 to 2 upon 45 inclusive, which is here. Try to leave the answer in fraction. It's better to leave the answer in fraction. This question is over. Let me show you this whole solution here. In this question, this equation is very important. Make sure you understand this equation through this given information. Sorry. The next question is 5. Set A consists of 10 digits. Some digits are repeated. Set B consists of 7 digits. 0 and 2 both are repeated. One digit is chosen at random from each set. The random variable x is defined as the sum. Now this is very important, sum of these two digits. The operation is addition. We will use the new possibility space diagram here, and I already have discussed that possibility into my previous lecture of this topic, lecture 1. I'm sorry. According to new possibility space, we write the probabilities here. We mention the probabilities of the numbers here and here. You should watch the lecture 1 of this chapter in order to understand the concepts of this chapter very well. we need probability x2. Here are two 2's. This 2 is from set B and this 2 is from set A. Therefore, the probability of this 2 will be 3 upon 7 times 6 upon 10. It's here. And the probability of this 2 is 4 upon 7 times 3 upon 10. And the final answer is 3 upon 7. Shown. Construct the probability distribution of x. Since x can take these values 0, 2, 4 and 6, therefore the table will be this. You all know how to get the probabilities of these numbers. We already have done the probability for number 2. Similarly, you can get the probability of 0, like 4 upon 7 times 6 upon 10. That will make 12 upon 35 and so on. Let me correct few probabilities. This number should be 30 upon 7 and the rest is fine, I guess. Now we need the expectation, mean and variance. This is, I guess, 60 upon 70 and this is 18 upon 70 and the final answer is 13 upon 7. This is the way to get the mean. You just need to take the sum of the products of these numbers. I mean, multiply these two, these two, and these two, and just add the results. So this is the way to get the expectation. For variance, you just need to square these things. I mean, first square this number and then multiply this square number with this probability. I mean, 2 square times this, 4 square times this, 6 square times this, and so on. This will give you ex square. This is capital X and this is also capital X square. And this is the formula of variance. And leave the answer in fraction. Now the last part of this question is, given that x is 2, this is the conditional probability question. Given that x is 2, find the probability that the digit chosen from set A was 2, meaning they are talking about this number. So this will be the denominator and this will be the numerator according to conditional probability rule. And the answer is 0.4 or 2 upon 5. The next question is 6. Sankit plays a game using a bias die which is twice as likely to land on an even number as on an odd number. Now this is very important. The probability for even number is twice than odd number. So by using ratio method, we can do this. Even, odd. I'm sorry. If odd is 1, then even will be 2. And the sum of ratio is 3. Therefore, the probability for odd is 1 upon 3 and the probability of even is 2 upon 3. The question, part 1 is find the probability of throwing an odd number with this die. The answer is 1 upon 3. Here is the answer. Now the question part 2, before going on to part 2, we just need to understand this thing. Sankit throws the die once and calculates his score by the following method. If the number thrown is 3 or less, like if n is 3 or less, then he multiplies the number by 3 and adds 1. I mean, this is the way he gets his score. 3n plus 1. Second condition, if the number thrown is more than 3, he multiplies the number thrown by 2. When the number is more than 3, then he will get his score like this, 2n minus 4. So there are two ways to get these scores. Well, show that probability x8 is 2 upon 9. Now this is very simple. You know, you can get score 8 by throwing the number 6. When he will throw number 6, then he can get score 8. I'm sorry. So to get 8, the number thrown should be an even number. This is the probability of one even number, of an even number, and 1 upon 3 means the specific number 6. Let me explain you this thing here. The probability of even number is 2 upon 3 in general. So there are 3 even numbers, 2, 4, 6. So 2, like 2 upon 3, 2 upon 3, let me correct this. This is x, this is x, this is x, and the total probability is 2 upon 3. So x will be 2 upon 9. So probability of a specific number is 2 upon 9, and probability of all 3 numbers is 2 upon 3. And here is the answer. So when you will talk about all even numbers, then the probability is 2 upon 3. And when you will talk about any specific number like 6 or 2 or 4, in this case number 6, then the probability of that number is 2 upon 9. Make sure you understand this concept well. Now the next part is find the mean and variance. I'm leaving this part. You all know how to get the mean. I'm sorry, I think its mean is given, we need variance. Let me correct this. This is capital X, and this is also capital X. I'm leaving the calculations of mean and variance. Given that the total, now before going on to part 4, we need to understand this concept. Sandkit throws the die twice, meaning this is the one throw. So when he throws the die twice, then we can get these things. Like we will get these scores 4, 4, 4, 6, 4, 7, 8, 10, like these scores, for example, from this table. Find the probability that the total of the scores on the 2 throws is 16. Now this is very simple. To get 16, the scores must be 10, 6. I mean, on one throw, he should get 10, and on the other throw, he should get 16. 6, that will become 16. 6, 10, 8, 8. These are the possible scores, possible values of x in order to get 16 score. And you know, 10. The probability of 10 in the table is 1 upon 9. You just need to take probabilities from the table. These probabilities are from the table, and this is the final answer. Now, last part is, given that the total, this is the conditional probability. Given that the total of these scores on the 2 throws is 16, find the probability that the score on the first throw was 6. So, according to conditional probability rule, this must be the numerator and the total will be denominator. Here is the final answer. Let me show you the whole solution again. Sorry. The next question is 10. Judy and Steve play a game using 5 cards. Judy chooses a card at random, looks at the number on it, and replaces the card. So, with replacement events. Then Steve chooses a card at random, looks at the number on it, and replaces the card. If the two numbers are same, are equal, or same, the score is 0. Otherwise, the smaller number is subtracted from the larger number to give this score. This is very simple. There are two ways, like Judy and Steve, and the rule is subtraction. 3 minus 0 makes 0, 4 minus 3 makes 1, 5 minus 3 makes 2, larger minus smaller. These are the possible values of x. Since all probabilities are equal, like 1 upon 5, so no need to mention the probabilities here. I mean, you just need to stick with the old possibility space, which you have done in O level. So when probabilities are equal, so there is no need to mention the probabilities. You can solve the question in the same way as you did in O levels. So probability of getting 6, there are 25 numbers to all together. So, and there are 2 6. So the probability of number 6 will be 2 upon 25. There is no need to do this thing. You just write 2 upon 25 here. You just need to write 2 upon 25. Although this is fine, but it's not required. You can just do, there are 2 6 out of 25, therefore the answer is 2 upon 25. Draw up a probability distribution table. This is very simple. X can take these values from 0 to 6. So here are the values of x and their probabilities. You know how to find the probabilities. Let me tell you how to get the probability of number 0. There are 5 zeros, so 5 upon 25 here. I mean, don't simplify the fractions. And the total should be 1. Calculate the mean score. You all know how to get the mean. I'm leaving the calculation of mean for you. This is capital X. The next part is, if the score is 0, now this is very important. If the score is 0, they play again. That means the match will be drawn. If the score is 4 or more, then Judy wins. Otherwise, Steve wins. To win, the score is 4 or more. They continue playing until one of the players wins. Find the probability that Judy wins with the second choice of card. Now this is very simple. Let me discuss the solution of this question over here. This page is question number 10. All right, I think I am here. Yeah, I just want to add a page here so that I can explain these two parts in detail, part 4 and part 5. Find the probability that Judy wins on the second choice. So to draw the match, the score must be 0. And the probability of 0 is 5 upon 25, which is 1 upon 5, which is 0.2. And to win the match, the probability should be 4 or more. According to this table, this is 10 upon 25, which is 2 upon 5, which is 0.4. Now, Judy wins at the second choice, with the second choice. This is part 4. Second choice means the first match should be and must be drawn. So the probability to draw the match is 0.2 and to win is 0.4. The answer is 0.08. Now in the same way, we can solve the part 5, which is n choice. What if I ask you, Judy wins on the with this third choice. This is on with the second choice. If Judy wins or Steve wins with the third choice, then there should be two draw, two matches to be drawn, and the third match uh, should be. Judy should win the third match. Third choice means the first two matches must be drawn, and the this match must be won by Judy or Steve. So this is for the third choice. If you want to write this in as a formula, it will become 0.2 power 2 into 0.4. So third choice means this 0.2 must have power 2. Similarly, for the fourth choice, this should be 3 and 0.4. For the nth choice, this should be n minus 1 times 0.4. So this is the answer of the last part, the n choice. This was required. Judy wins with the n choice of the card. So I tried to explain this in detail. Here is the answer, 0.2 power n minus 1, 0.4. Now the next question is 12. Let me discuss question 11 to understand the combination method. A team of 4 is to be randomly chosen from 3 boys and 4 girls. Now the important thing is the selection is of 4 people. We need 4 from 3 boys and 5 girls. The random variable x, now this is very important. The random variable x is what? The random variable x is the number of girls. You must understand the meaning of x in the question. X means number of girls. So draw up a probability distribution table for x. So in order to draw the distribution table, you must understand how to get the minimum and maximum value of x. I already have discussed this concept into my previous lecture, in my previous lecture of this chapter. So you should watch that lecture to understand this concept in detail. I'm just going to explain this concept in short. Let me explain this concept here. This is page number 11. I'm 11. Is this page? This page is here, I guess. Yeah. Let me add a page here to explain you how to get the values of x. So this x will take these values: minimum, maximum. Since we need 4 students, and you just need to write girls here, boys here, girls here, and you just need to write the available numbers 5, 3, 5, 3. Now try to take 4 girls. Try to take all girls, which is possible because this number is 5. This number is greater than the requirement. When the number is greater than this number is greater than the requirement, you can take this option. And when you will take all girls, then there will be no boys. So maximum value of x is 4. Try to take all boys here, all 4 boys, which is not possible in this case because boys are less in number, less than the requirement. So this option is not possible, so you should go to this option. Take this option, 3 boys with 1 girl. So the minimum value of x is 1. So x will take these values 1, 2, 3 and 4. This is the way to get the values of x in these type of questions. Sorry. So x will take these values. X cannot take 0. You just need to ignore this value. X will take values from 1 to 4 inclusive. And in this question, since the events are random and without replacement, so must use combination in this question to make the calculation simple. So for one girl, this must be 5C1. There will be 3 boys, 3C3, and for probability, you should write 8C4 here. Again, you need to watch the lecture 1 of this chapter on YouTube to understand the concepts of this chapter in detail. We use combination when the events are random and without replacement. This x is capital, and you know how to get mean and variance. This is the next page. Now let me discuss question number 12. The next question. A factory makes a large number of ropes with length 3 or 5. There are 4 times as many ropes of length 3 as there are ropes of length 5. You can use ratio method for this. 3, 5, sum of ratio. There are 4 times, so this should be 1, this should be 4, sum of ratio will be 5, so the probability of 5 will be 1 upon 5 and this will be 4 upon 5. So by using this concept, you can get the answer. Now we need expectation and variance. You all know how to get the expectation. You just need to multiply this with this and this with this and just add the results. And for variance, first square this number and then multiply this with this, square this number and multiply this with this and get ex square. And then for variance, write 61 upon 5 minus square of this number, which is here. 2 ropes are chosen at random. Find the probability that they have different lengths. This is very simple. The lengths could be either 3 or 5 or 5 and 3. And here are the probabilities. 3 ropes are chosen at random. Find the probability that their total length is 11. Again, a very simple question. To get 11, the ropes should be of these lengths, like 335, 353, 533. You can use factorial for this. The result is 3 factorial. There are 3 ways. 1, 2, 3. So just write the answer of 1 and multiply the answer by 3. Or you can do this question in this way. Probability three, 3, 5 in any way. So 3 factorial over 2 factorial, 4, 5, 4, 5, 1, 5 times 3. This is the another way. Now the next question is 13. A spinner has 5 sides numbered 1, 2, 3, 4 and 5. When the spinner is spun, the score is the number of the side on which it lands. The score is denoted by the random variable x, which has the probability distribution shown in the table. P, this is very simple, since you know the total is always 1, therefore probability, by adding all the probabilities you can get the value of P. Here is the value of P. A second spinner has 3 sides 1, 2, 3. These scores when this spinner is spun is denoted by y, and these are the probabilities. Here we have to use the new possibility space. This is the new possibility space, which is we already use this possibility space in question 5. In this type of possibility, must write probabilities here. 0.3, 0.15, 0.3, 0.2, 0.05. This is I think 0.3, 0.5, 0.2. We already have used this type of possibility in question 5, and now we need what? We need sum of these scores. Sum of these scores, I mean, you just need to, this possibility is not right. I mean, this is not the right possibility space. You should use this possibility space instead. When there are two operations like sum and product, then use this possibility. This possibility will make the calculation simple, uh, will save your time as well. You should go for the listing. I mean, list the outcomes 1 1, 1 2, 1 3, 1 4, 1 5. Use this possibility when there are two or more operations like addition and multiplication in this question. I mean, this possibility will make the calculation difficult. To make the calculation simple and easy, and in order to save time, this possibility will be good for this type of questions, or these type of questions. Part 1, the sum of these scores is 4. You just need to select the options. The sum of the score is 4. This option, and this option will give you a requirement. So for this option, 1 3, probability is 0.3 into 0.3. This is here, and here. The last part, the product of these scores is less than 8. There are so many numbers whose product is less than 8, so go for the alternate method. Take these numbers, these 5 numbers, because the product of these number is greater or equal to 8, and use this result. 1 minus product of greater equal to 8 and product greater equal to 8 is here. The probability is here. So this is the easiest way to solve these type of questions. Now, last question of this class, and this is question number 14. The random variable x has the probability distribution shown in the table. Two independent values of x are chosen. Now this is very important. You are taking two values of x. The random variable y takes the value 0 if the two values of x are the same. Otherwise, the value of y is the larger value of x minus the smaller value of x. So here we are using the subtraction. So go for the results. I mean, there is no need to list the outcomes. These are the results, like 2 minus 2 makes 0, and so on. And in this question, we had two operations, addition and multiplication. That is why I went for the listing. This means list the outcomes. And here there is just one operation, subtraction, so just go for the results. 2 minus 2 0. Don't go for the listing. These are the possible values of x. X will take these values, and you know how to get the probabilities. Probability of 4 is here, 5 is here, and total probability is 1, and this is the way to get the mean. Well, this is all of this lecture, and this is the advice for me and for everyone. Be honest. I hope this lecture will help you to understand the concepts of this chapter very well. Allah Hafiz.